So this video is going to help us make sure we understand how to find absolute extrema, and then we're also going to talk about Rolle's theorem in an example involving that. So when we want to find the absolute extrema of a particular function, it's a pretty easy process that we can follow in order to do that. So we're going to use an example to kind of outline those steps so we can get used to this process of something that we'll do quite a lot. So we start out with a function. Let's say we have x to the fourth minus x squared plus 1, and we want to find the extrema on of our function f on the interval -1 to 2. So we have a particular set interval, and our goal is to find the absolute extrema in particular, not the locals, but we're just going to find the absolutes. And as you remember from the extreme value theorem that we saw in class last time, we know that these are going to exist as long as this is a continuous function. And since we have a polynomial, we know that that's continuous, so we know for sure that it's going to have absolute extrema. Now the next thing to remember with trying to find absolute extrema is they can occur at one of two places. They can either be at the endpoints, if you remember the examples we did in class, or, so if you have a function, we'll just kind of draw a picture over here, whatever, and this is your interval from here to here, right? The extrema could be at the endpoints, or they could occur at where you have local maxes or mins. And if you remember, those local and maxes and mins occur at places where your derivative is 0 or your derivative doesn't exist. So in these problems, the first thing you want to do is take the derivative of your function and find your critical points. So that'll be always the first step, and so we're going to do that now. So for us, our function, we're going to take the derivative. So f prime of x is 4x cubed minus 2x. To find the critical points, we're going to set that equal to 0. And we can factor out a 2x here, I believe. So we get a 2x minus 1 equals 0. So this gives us possible critical points of x equals 0 and x equals 1/2. So those are the two solutions we get from setting those two pieces of that equation equal to 0. So we have two possible values where our critical points could be. Actually, it looks like 2x. If we take an x, actually get an x squared here, correct? So we're going to be a little bit careful. So it looks like we actually get plus or minus the square root of 1/2. So we actually get 3 critical points. So just be aware of that. So the next thing you're going to do after you do all that, and be very careful with your factoring, as I was not all that careful there, but just be careful with your factoring. Set each of your factors equal to 0. Once you have your full equation equal to 0, solve for x. We get x equals 0. X equals plus or minus the square root of 1/2. Now what we want to do is we want to test f of c for every point, for every critical point in our interval. So we're going to throw out any numbers that are outside of our interval. All right, and we're also going to test the two endpoints. Okay, so we found all the critical points in step 1. The second step is to take those critical points that are inside your interval. So if there's any that lie outside of the interval, you'll throw those out. And test the two endpoints. So in this case, it looks like we have 3 things. 0, which is inside our interval from -1 to 2. Square root of 1/2 is definitely less than 2, so that one's good. And negative square root of 2, also negative square root of 1/2 is certainly going to be bigger than -1, so it will also be in our interval. So it looks like all 3 of these, so we're going to end up in our example having, I think we're going to test a total of 5 points. The 3 critical points and the 2 endpoints. So that's how we're going to actually end up testing this and decide where our absolute maxes and mins are. Okay, so here are all the things we're going to test. So f of -1, f of -1 over the square root of 2, or the square root of 1/2. F of 0, that's another critical point. f of square root of 1/2, and f of 2. So those are all the values that I want to calculate in order to test which one is going to be the largest and which one is going to be the smallest, because my absolute maxes and mins will have to occur at either one of these two endpoints or at one of these three critical points. And so that's why I test only those things, because we know that those are the only places that our absolute maxes and mins could be. So all we have to do is now find the values of these 5 things. Just keep in mind we're plugging it into f, not f prime. So be careful, because you have just found the derivative, but just be careful, you don't want to use the derivative, you want to use your original function. And our original function was x to the 4th minus x squared plus 1. So if I do that here, it looks like I'm going to get 1. And if I do this one, negative 1 over the square root of 2 to the 4th minus a negative 1 over square root of 2 squared plus 1, that looks like it's going to be 3 over 4. If I plug in 0, it looks like I'm going to get 1. 1/2 will give me 3/4. And if I plug in 2, 2 to the 4th minus 2 squared plus 1 is 13. Okay, so I plugged in all of my values. And I have all the values for my potential endpoints and my critical points. And the question now is which one is the absolute maximum and which one is the absolute minimum. And so that's your third and final step, is just the largest f value is your absolute max. And your smallest x value is, f value is your absolute min. So if we look down this list, it looks like the absolute maximum is going to be 213, right, the xy coordinate point. I usually like to give my answer as an xy coordinate point so you can kind of see like what the answers are. So there's your absolute maximum. And the absolute minimum looks like it occurs at 2 places. So we have 2 absolute minimums. Those occur at negative 1 over the square root of 2 3/4 and 1 over the square root of 2 3/4. So you can have more than one if in fact your smallest value is repeated for these things. So it turns out that the 0 and the negative 1 actually don't come into play here. They're not a minimum or a maximum. So we have 2 absolute minimum at 1/2 square root of 1/2 and negative square root of 1/2. And the y value is 3/4, and the absolute maximum is at 213. So this process is pretty much the same for any of these that you see. You're just going to be dealing with different kinds of functions, and you're going to have to be really careful about how you find those zeros and or places where that derivative is equal to 0.